Welcome one and all. I am Dhananjay Pise, working as an assistant professor in Department of Engineering Sciences, AISSMS Institute of Information Technology, Pune. Today we are going to see the introduction to power plants. This topic is from the course Systems in Mechanical Engineering for first year engineering students. First one is the solar energy power plant. Solar energy is defined as the energy which originates from the thermonuclear fusion reactions occurring in the sun. So, whatever the radiations we are receiving from the surface of the sun to the earth, so with that we can provide the 10,000 times of power demand of the world. It is around about 178 into 10 raised to 5 megawatt. So by using thermal and photovoltaic conversion technologies, solar energy can be utilized for various purposes like solar water heater, solar distillation plant, photovoltaic cell, likewise. So here we have to use the solar collectors, that is flat plate collector or parabolic concentrated collector. So here you can see the diagram. So these are the collectors, and with these collectors we can collect the solar energy, and that can be used for heating the fluid for the power plant. So here the contents or the parts of the solar energy power plants are the collectors, then tubes for circulating the fluid. So here we have the pump for circulation, then we have solar superheater over here, then steam generator. It is connected with the steam power plant basically. So this steam will be passed on to the turbine, and the high pressure steam will rotate the blades of the turbine, which is connected to the electric generator and transformer. The steam coming out of the turbine will be converted into the water, that will be the mixture of steam and water. So here we have the condenser for converting it into again the water, and here the pumps to circulate again it through the solar collectors. The simple diagram you can see over here. So here we have the turbine which is connected to the generator, then condenser, we have the feed pump, then solar collectors. So this one is a flat type of collector, and here it is a parabolic type of collector. So when the water is passed through the solar collector, it will be converted into the steam. So this high pressure steam with the help of nozzle will be inserted onto the blades of the turbine. So here pressure energy of the steam will be converted into the kinetic energy, and inside the generator kinetic energy will be converted, or the mechanical energy of the turbine will be converted into the electrical energy. The steam here will lose its pressure and temperature, and will at the output of the turbine we will be having mixture of steam and the water droplets. So to convert it into again the water, we have to use the condenser. So here the cool water will be circulated inside the condenser so that the temperature of the mixture will be decreased and it will be converted into the water. So again, with the help of feed pump, we can circulate the water through the collector where it will be converted into the steam. Then steam will be inserted onto the turbine blades, and again so on. The cycle will be continued. So this one is the solar power plant. The advantage is it is low cost. The solar energy is available in ample amount of quantity. It can be converted into heat and it can be used for converting water into the steam and for the next application. Disadvantage of this solar energy is that depends upon the weather condition, the amount of heat energy we are receiving will be varied. It can be used only for the daytime. So these are the two disadvantages of the solar energy. Next one is the steam power plant. Now here, instead of solar energy, here we are using the coal power plants to convert it into the water will be converted into the steam. So here we have the boiler inside which the coal will be used for making the heat energy, and that heat energy will be used for converting the water into the steam, and that will be passed to the steam turbine which is connected to the generator and then transformer. So instead of here you can see the simple diagram of steam power plant. Solar collectors are now replaced by the boilers. So here the steam power plant converts the chemical energy of the fossil fuels such as coal, gas, etc. into the mechanical energy into the turbines, and that mechanical energy will be converted into the electrical energy with the help of the generators. So contents of the steam power plants is the boiler, then steam turbine, generator, condenser, pump. So here the water will be circulated inside the boiler with the help of pump. So high pressure water will be converted into the steam inside the boiler, wherein we are having the fossil fuels which are generating the heat energy. So water will absorb the heat energy and it will get converted into the steam. So this high pressure steam will be impinged onto the blades of the turbine with the help of the nozzle, and here the pressure energy of the steam will be converted into the mechanical energy, and that will be converted into the electrical energy with the help of generator. So at the output of the turbine we are having low pressure steam and water droplets. To convert it again into the water, here we have to use the condenser. So cold water will be circulated inside the condenser which absorb the heat energy of the mixture, and it will be converted into the water again, and again it will be passed through the pump inside the boiler and the cycle will be continued. So this is the steam power plant. Steam power plant can respond rapidly to the changing loads without difficulty. The portion of steam generated can be used as a process steam in different industry as well. It can be located where conveniently near the load center, that means for the application, near to the application. It can be set into the industrial zone or application zone so that we can reduce the transmission cost and efficiency can be increased. Steam engines and turbines can work continuously under an overload of 25%. Cheaper fuel can be used. The space required is very less as compared to the hydroelectric power plants, but its maintenance and operating cost is high. The cost of plant increases as the need of increase in temperature and pressure is there. Large quantity of water is required for this, and handling of coal is very difficult in this case for the steam power plant. So these are the disadvantages of the steam power plants as well. Next we have the nuclear power plant. Now here the boiler will be replaced by the nuclear elements, and this nuclear energy or nuclear reactor will be used for generation of the steam. Heat energy will be supplied now with the help of nuclear reactor instead of the boiler. So this whatever the heat produced inside the nuclear reactor, it will convert the water into the steam. So the rate of heat release in the nuclear reactor is extremely large as compared to the combustion of coals or fossil fuels inside the boiler. So the heat energy is produced by the nuclear fission is very high. When a neutron is here, you can see the nuclear reaction, nuclear fission. When the neutron is bombarded onto the nucleus, such as uranium, so the fission process starts and it liberates a large amount of heat energy. So it will goes on multiplying so that here we can have more number of or more amount of heat energy. So here you can see the structure of nuclear power plant. Here we have the nuclear reactor inside which the neutron deflector is there, then radiation shield is there, control rods are there for controlling the reaction, then moderator fuel is used. So here the coolant in this case, suppose water, so water will be circulated inside the nuclear reactor. So whatever the heat energy generated by the nuclear fission will be used for converting the water into the steam. So this hot or steam will be passed through the heat exchanger, wherein at the right hand side we have the actual steam power plant. So here we have the circulation of water. So the steam will give the reject the heat towards this water, and here water will be converted into the steam. So that steam will be passed on to the turbine blades with the help of nozzles. So here kinetic energy will be converted into the mechanical energy. So turbine is connected to the generator. So it will produce the electrical energy. At the output of the turbine, we have the mixture of water droplets and steam. Here we have the condenser, feed pump, and again water will be circulated over here. So we have here the two circular circulation kits of the water. The first left hand side kit will be used for circulation of water inside the reactor for generation of steam. So that heat energy will be exchanged to this second water circular kit, wherein water will be converted into the steam, and that is will be used for generation of electricity. So here the key role will be of heat exchanger and nuclear reactor. Advantages of nuclear power plant is that it doesn't require much space as compared to the conventional power plants. Nuclear fuel is charged to power plant frequently because it has a relatively long life. The weight of nuclear fuel required is very small as compared to the coal. Nuclear power plant produces valuable isotopes which are used for different purposes. These are not affected by adverse weather conditions. The operation of this power plant is more reliable as compared to the other. Here we don't require any combustion of air or thermal stack is or losses are very low. Whereas investment cost is very high as compared to the other. The burn fuel is highly radioreactive. The danger of radioreactivity is more. It cannot be operated efficiently at varying load. The maintenance cost is also high, and disposal of fission products is a big problem for the nuclear power plants. Thank you.